So if you have a formula that's compounded continuously, so that means it's always getting compounded. So not only just every second, every millisecond. The amount A after T years due to a principal P invested at an annual interest rate R compounded continuously is A equals P e to the RT. So anytime you see a problem that says that it's compounded continuously, so now they're not saying it's compounded annually or semi-annually, so a concrete number of times. Now they're saying it's compounded continuously, so it's always getting compounded. You use this formula. So let's look at the same example. You've got $20,000 into an account that's earning 5% interest, but now we're compounding it continuously, which tells us that this is the formula we have to use. What's the value of the investment after 6 years? So A equals the principal times E to the interest rate, which is 0.05, times the number of years, which is 6. When you substitute that into your calculator, you'll get $26,997.18. So the amount of interest that they earned on this account in 6 years, well, it ended with $26,997.18. The account started with $20,000. So they earned a total of $6,997.18 over that 6-year period. So again, looking at simple interest, it was $6,000. When we looked at compounding annually, it was $6,801. And now when it's getting compounded continuously, it's almost $7,000. So the more times you're compounding, the more money you're going to make. Or if this is a loan, the more money you're going to owe. All right, let's look at some more examples. You have $1,000 to invest in a bank that offers 4.2% compound interest on a savings account compounded monthly. So this means that I'm going to be using the formula A equals P times 1 plus R over N to the NT. What annual interest rate do you need to earn to have the same amount at the end of the year if the interest is compounded, it should say continuously. So with a continuously, that means we're using this formula A equals P times E to the RT. So what they're asking for is what rate should I use so that I have the same end amount in an account that's compounded continuously versus getting compounded monthly. So in order to solve that problem, I need to know what that actual end amount is. So let's look at that first scenario. So the principal is $1,000. The rate is 4.2%, which is 0.042. The number of times it's compounded a year, it's compounded monthly, so that means 12 times a year. And the number of years that go by is they just said at the end of the year, so we're just going to assume that 1 year has gone by. When you substitute that in, you'll get about $1,042.82. So that's how much money is going to be in the account that's compounded monthly at an interest rate of 4.2%. So this question asked, what annual interest rate do we need to earn to have the same amount at the end of the year in an interest, if the interest is compounded continuously? So now I'm going to use this formula. I know the end amount I want is $1,042.82. I know my principal is $1,000. I don't know my rate. That's what I'm solving for, but I do know the time is T, or is 1, which would mean R times 1, which is just R. So I'm going to leave it like that, because again, T is 1. Okay, so now this is just an exponential equation. So recall from earlier sections, to solve an exponential equation, you get the exponential piece isolated. So we need to get this piece by itself. In order to do that, we'll divide both sides by 1,000. Now what I recommend doing is keeping things, don't plug things into your calculator until the very end, just so that you're not rounding anywhere until the exact last step. Okay, so that r is stuck in the exponent. So now that we have this exponential piece isolated, we can take the logarithm of both sides. I'm going to take the natural log. The reason I did that is because now I can use that power rule to write this r in front. And recall that the natural log of e is just 1. So this is the same thing as saying r times 1, which is just r. So r is the natural log of 1042.82 divided by 1,000. And again, that's because this ln of e is just 1, or natural log of e is 1. So that means that r is approximately, when you substitute that in, you will get 4.19%. So if you put $1,000 into an account that's compounded continuously, in order to get the same amount, you would have to have an interest rate of 4.19%.